Hi, how is everyone? Very happy to see you because the other session is quite good as well, so I'm very excited that you're all here. Hope this will be fun. So my name is Ingrid. I come from backend engineering and automation. I'm a very serious person when it comes to macaron. You've also probably seen me bounce and dance around before my talk, so this is obviously going to be a very, very serious session. I hope you're ready. I have a profound dislike for things that are unnecessarily complex, and we're going to talk about that quite a bit throughout the talk today. And I feel like complexity is a very, very vast term, and a lot of people are using it as a buzzword, so let's clarify what I mean by that. It can be anything from code complexity to system complexity, architecture complexity, the number of code paths, or the number of tests, or even how we describe an area and how accessible you make an area that you work in for new people with a different experience to join. I talk and rant a lot about security and culture in tech and building tools for engineers to help engineers be productive. So if you're passionate about any of those things, come find me afterwards. I think there's still an event tonight. Let's nerd about it together. I'd love to hear more about your experience. The reason why I love DevFest, it's my first DevFest, and why I love the space team that the organizers chose this year, which is a lot of fun, is that it reminds me of something that I grew up with, which is Star Trek. And there's quite a phrase that's very close to my heart, which is boldly go where no human has gone before. And to me, that means a lot of different things from, advancing technology and whatnot, but also sharing your culture and sharing your experience and your knowledge, but also learning from other people. I'm very passionate about travel, and I'm very passionate about sharing experiences across different backgrounds. And notoriously and quite badly, tech hasn't been the friendliest or the best poster child when it comes to sharing with other teams or sharing with other people. And more often than not, we put engineers in silos, where if you're a front-end engineer, you would describe yourself on average. I'm a front-end software engineer. I build awesome user experiences. That's my job. Done. And then if you're a back-end engineer, you might say something like, I build highly scalable services. Yay. And then if you're a production or a site reliability engineer, you always very often say, my job is to keep the app running and available. And the problem, or we're not so great about when we isolate and we put people into categories and specialties, and there's been this chat forever, should I be a generalist or should I be a specialist, is that it creates a lot of fear. And it makes people quite notoriously feel like they don't belong, or everyone has heard the phrase imposter syndrome, which is very fun, creeps around a lot in our industry. And fear can creep in on a different level and have impact on different levels. You can be afraid to make changes because you feel like you're not quite good enough, or you don't quite understand what you're making or what you're doing. There's this image of a dog that I have no idea what I'm doing. My code works. I don't know why. You can be afraid to fail. Failure is not the prettiest feelings, but I think it comes quite often. Failing can also cause an outage. So you can be afraid to literally cost your company millions and millions of dollars, depending who you work for. But usually an outage is seen as a quite serious thing in some companies, which can also cause you to have a different opinion. I don't quite know what I'm doing. I'm not sure. I think this is not the way it should work, but I'm not sure, so I'm just not going to speak up. And that's a problem. And it's quite easy to see how we've managed to propagate this culture. The complexity of software is rising exponentially, but we still lack proper developer tools. There's people in this room that still run Nagios. I've heard that right before my talk. We still run that. We still, the console, like the developer tools in the browser are awesome, but I think Chris said yesterday that they're getting more and more complex as well. And while they're very, very powerful, user friendliness is something that we still have to keep in mind. Some companies make it unsafe to fail, where if you fail, you cause an outage, you're fired. That's not cool either. That's not how you grow. That's not how you continue to be creative. And then more often than not, it's just so slow and painful to mitigate failure there's still not a trivial, it's rolling back from production once an incident happened, it's still seen as something that's non-trivial. It's not the norm. More companies than not don't do that. But if you were to look at, regardless of what our background and what our experiences or who we work for, if you were to sum what we really, really want as engineers, I think a very simple way of looking at it is that I want to understand the impact of my change. And I want to be able to own it and support it. There's nothing better than being able to jump on board and ask questions and like be able to troubleshoot a problem. Walking home after you figured out a really, really difficult problem is the best feeling in the world. It's one of the reasons why I love this job. But with the lack of proper tooling or sometimes support from your team or even the data that is more noise than anything else, debugging is seen more as an art. It's seen only as a privileged area for the very few that have been in the company long enough to understand what the hell is going on. And it shouldn't be. You should be able to jump in and own your feature and be able to get answers in the hands of customers and be productive rather than feeling frustrated or feeling like you have to go through 1,000 dashboards and you don't quite know what's going on, even if you spent 5 hours looking at it. So let's talk a little bit about impact and how you estimate impact for your system. Obviously, when you're a serial production engineer, a product engineer, and you want to build a feature that displays a list of articles, obviously there's probably some research there that would make you understand how your customers are going to use that and what they want, and there's design work, but we're not going to talk about that. We're going to talk more about what happens when this is actually deployed in production. So hopefully you have a bunch of tests, it all goes really well, and now someone can actually go to the browser and say, hey, myapp.com, give me the list of all the articles that are in draft state. So what happens when a customer actually goes and does that? Well, if we were to look at the system behind it, because we're trying to estimate the impact that this has on the system rather on the end user, it would look something like this. There's a browser, obviously. And then there's the DNS that does some things. We're going to go into that. And then there's a TCP three-way handshake, whatever that means. There's backend, and then there's storage. So if you look at the list of all the things, all the hops that your request has to go through to be able to return the pretty list of articles that you've just deployed to production, it doesn't look like the friendliest thing in the world. DNS, domain name system, is something that's notoriously complex. People that talk about it seem to have like 3 PhDs, where it's usually described as not being the most beginner-friendly or accessible thing. If you read the RFC, try it if you want to punish yourself. It's quite interesting. And then there's TCP three-way handshake. TCP is a protocol. I'm sure most of you know that. Protocols are not necessarily renowned for being the simplest things. Again, if you read an RFC or the HTTP manifesto, you're probably going to have a very, very fun time. So just by looking at this, when you're trying to learn more about systems, but you don't quite know where to start, it looks scary as hell, right? Like, it looks super, like, where do I even? There's so many things, where do I start? And I think, again, iterating, the problem is that we would be pretty good at like breaking down, giving like a scientific explanation of all of them, but we don't spend that much time looking into a way to make it accessible. So let's try to break it down together and do that. So if you look at a simpler explanation of what we're trying to do, we have a resource somewhere that we want, and we're just trying to go and get it. That's all this does. And then you have to do different things to actually get to that. So to me, that's a coffee addict. Sounds an awful lot like, how do I go and get a coffee? Coffee is a resource that I want. How do I go and get a coffee? Especially when I'm in a city like Nantes where I have no idea where coffee places are. So what you would do is that you jump into a taxi, and then you'd give the taxi driver the address, and then hopefully they'll say, I know where that is, but more often than not, they're like, what? So you have to look at a map to find that address. And then hopefully they drop you at the front door and not to some weird other location where you have to walk for another few minutes. And once you're in, you place your order. The barista is going to make your coffee with it, like he's adding his own like talent and experience and flavor. He's going to serve you that coffee, and that coffee contains a bunch of ingredients. So it matches quite well the system that we described before, except it actually looks a lot simpler or more understandable. So let's dive in and see if it's actually as scary as it looked initially. So first of all, the browser. The first thing that you do when you're trying to get somewhere and you get into a taxi is that you're giving the person your destination. And the human at the end of that conversation is going to do something with it. It's going to try to break it down by neighborhood and like analyze how far it is and what's the zip code and if it's even in the same city, which hopefully it is. Sometimes it happens. And your browser does the same thing. When you're typing the URL and hit enter, what the browser would do is that it would split it according to a pattern, where you have a protocol, you have a host, you have a port that can be optional because HTTP defaults to port 80, HTTPS to port 443. And then you have that path to the resource and then the query. So in the example that we took earlier, this will become HTTPS, appmyapp.com, 443, which is missing, can miss because it's what we would default to in the case of HTTPS. And then articles list all, which is the path to our resource. Cool. So say that they don't know where the coffee place that I'm trying to go to is. What do they do? Well, first, they would have to go through their memory of like, have I been here before? Have I seen this place before? And this recursive inner interrogation that a taxi driver would do, the browser has to do as well. It has no idea what app.myapp.com means to it in the beginning, so it's going to look at some records to determine if it had seen it before or not. And that's called cached records. That literally contains a list of addresses where you've been before so that it knows how to get there fast. So it would first look at the browser, and then at the OS, and then router, and then something called local DNS. And we're going to go into that in a little bit. And then if it doesn't know where it is, it's going to make a request and ask someone else. And that someone else is DNS, so we're going to dive into that. DNS was something that, a little bit of history, because I think it's fun. It was invented in 1983, and in the beginning, I hope I'm not wrong about the year, but I don't think I am. And in the beginning, it was pretty much a file called hosts that contain a list of addresses mapped to IP. So for example, if you were to go to Microsoft.com, it would have the IP address where Microsoft.com exists. To this day, even in the latest version of Windows, there is still a host file on your machine that does the exact same thing. And that's where the OS, when you're getting to the OS level and it's doing a lookup on your records, that's where it ends up. So DNS functions like a phone book of the internet, or because we don't quite use phone books anymore, we're yellow pages as we used to in the early 90s. God, I'm old. We now use Google Maps or a bunch of other alternative solutions. And DNS is pretty much like that, where you're giving it you're giving it a place, and it just returns you an address, except that computers don't really understand addresses. Browsers don't really understand addresses the way we do, but they understand IPs. So the first request is to something to your internet service provider, because it needs to be able to talk to the outside world, so that's the first hop that it goes to. And then it goes to something called root name servers, and you can think of it as kind of like a world map that knows everything. It knows all the continents and all the countries, and it basically knows where to point you. And from that, it goes recursively to something called top-level domain name servers, or TLD, which should be .com in this case, appmyapp.com. .com is like the top level, or think of it as a country, I guess. And from there to, now that it knows what .com is, where it is on the map, it asks it, hey, what's myapp.com? Do you know anything about that? And the top-level domain is going to go, I don't know anything about that, but I bet you this node over here knows more. So it's going to make a call to that, and to something called authoritative name servers. So they're kind of like the city council of the internet, if the top-level domain is the country. And it's going to return the address of the neighborhood where your coffee shop is. And from there, it goes to the actual, finally, it goes to the actual app. It finds app.myapp.com, which is called the DNS record, which is exactly what we needed. And because, again, browsers understand IP addresses, the information that's actually returned back to the browser, and this is where you should go, it's going to be an IP and a time to live. And that's an address record. So now the browser finally goes, oh, you meant 52.203.163.15. I'm going to take you there, because I know what that means. And on the way, it kind of works a little bit like our brain. Once you know where something is, hopefully you get to store it for a little while, so it updates all the previous locations where it once looked at. So that's DNS. It's not that scary. What's really interesting about this, if you think of it, a really, really good taxi driver makes a difference, especially if you're late. I'm sometimes late. I'm not very proud of it. Can't believe I said that on video, but it's fine. So the difference that a good taxi driver makes is that when you're in a hurry, you kind of want to just go there. You don't want to wait a very long time. And if you remember the information that's returned, it also contains a time to live. The lower the time to live is, for example, if you have a really bad memory, then you're going to have to go through all this over and over and over again. And every time you're trying to go to that address, you'd have to go do the same lookup. So as you can imagine, this has quite an impact on your performance. So that's not cool. The higher the time to the TTL means the harder it is to make changes. So you'd have to wait that amount of time to be able to make changes. For example, if it's a taxi driver that's been in the industry for a while and they know one route and one good route, you're gonna have a hard time trying to stir the person to drive you on a different route. So that's not fun. So the reason why I think DNS is important and why it's not very straightforward, but it would be a good information to know for engineers, is that it can have quite a bit of an impact on performance. So we got there, we have the address, we're now at the front door. Cool. What the browser does, or what you would normally do, is that you wouldn't necessarily just barge in, right? You'd kind of do a little bit of assessment, like, are you even open? Or is there a bear inside? Or is it just too crowded that I just don't want to go in because no one's going to talk to me in time? And that's essentially what a TCP three-way handshake is, where your browser is going to send a request with to the backend and say, hey, I'm trying to talk to you. And then if the backend is not very busy, it's going to respond that, hey, I've acknowledged your request, and I'm waving back. You're good. You're cool. And then the browser is going to go, OK, peace to all of you. Now we can talk. You're a nice human or alien. We can talk. Cool. So once we've established that it's safe to go in, we can actually finally place an order for a coffee. Can I please get a cold brew coffee for here? And the way it's been done for many, many years, or the way you translate that into the request lifecycle that we're trying to simplify together, is that you'd make a GET request over HTTP 1.1, which has only one requirement: what's the host that it's going to receive the answer from this request. And that's worked for a very long time, except it is incredibly painfully slow. So here comes HTTP 2, and the advantage for that is that it would support full request and response multiplexing, which means you don't have to wait for the other person to respond or acknowledge your request before you can fire a new one. And the reason why this is important is because web pages are complex, and you don't just have one thing. You have CSS, and you have JavaScript, and you have a bunch of things that need to get downloaded when you're trying to visualize that page. And with HTTP 1, that takes forever, but HTTP 2 was brought on board to support exactly that. And the guys from Golang ran this experiment called Go for Tiles. It's actually really fun. I strongly encourage you guys go and have a look. Where you would load a grid and 180 tiled images that would eventually paint into this little golfer and big golfer. I'm not a Go engineer, don't judge me. And you can compare the performance of that on HTTP 2, which on a good connection or on a decent connection, even the one here, it would be pretty instant. And then on a HTTP 1, it would take quite a big time to paint. So the TLDR, you don't have to worry too much about the details unless you're curious. I'll put some links for you to read more about it. But the TLDR, if you care about performance for your app, which you should just switch to HTTP2. So let's talk a little bit about the record lookup. So we've placed our order, and our barista is looking at us and kind of going, oh, what the hell is a cold brew coffee, and what do I need to do to serve it? And that's exactly what happens when your request hits the database layer. For the purpose of this example, we're going to use MySQL, but it's very similar across relational databases. So MySQL uses something called a MySQL optimizer. So every time you're trying to run a query, the database is going to try to, first of all, explain that query and understand what you mean by that and what it would cost it in terms of resources or how it should actually go about returning it. And you can think of it as a very big storage room where you have to retrieve 20 ingredients. Obviously, if it's messy and there's no system, that it's not organized by any sort of system, chaos is also ordered, it's going to take you a very, very long time to get all your, oops, I've never done that before, sorry. It's going to take you a very long time to go and get everything and to be able to make what you're trying to make. And the way the MySQL optimizer does that, it's the exact same way a developer would try to understand the query as well. It would run an explain statement, explain followed by the query. And the output of that is pretty much a table with a bunch of information from the ID of the query to the type of the select, to the table, to some attributes on the table, et cetera, et cetera. But the first thing that you should worry about, or you would like to know in terms of like performance for that query, is if whether or not it's going to hit an index. And what an index is exactly that system that makes you remember where something is. And it's used to find rows and specific column values quite quickly. So it's basically a pointer to the table row. And because it's something that MySQL needs to store alongside all your data and all your tables, an impact of it would be that it would increase the space usage, and it would also increase the cost of the write operations. So every time you try to insert data into that table, it would have to also be indexed. So the write operations would increase, but if you need to support, if you're more read, or you need a better performance for read queries, then this is something you should look into. Something else that the MySQL optimizer is going to give you is the estimated number of rows to be examined. And obviously, the lower the number, the better the performance of the query. If you're trying to bring back or hold together 20 items, you're probably going to have a hard time and struggle a little bit, especially if your balance is good, as it was mine earlier. But if you have to bring back fewer items, you're going to be more performant. And then there's this extra column that I feel like it's the biggest lie or the biggest trick that MySQL plays on you, because every time that a query cannot be executed using an index, you're going to see something like using file sort or using temporary. And it's actually not doing a file sort. It's implemented as quick sort, but MySQL likes to troll people, I guess, so they named it that. But what I guess what you need to keep an eye on is that if you do see that there, then that means that your indexes for that table don't match the type of query that you're trying to execute. And you should probably decide if it's even worth running that query or if you should go and actually add an index. What's really, really cool about it is that you can't really precisely estimate the performance of a person executing a certain action, but you can with MySQL. So they actually have a formula, which is really cool for the math geeks out there. I won't try to repeat it because it's quite long, but basically it exists, and it would give you a number of the number of lookups that your database will have to do to be able to return all your information. And I put a link there if you want to read more about it. It's quite interesting. It's a good way to estimate how performant your query is going to be in terms of numbers. The thing about your database, and what people don't very often we forget as engineers, is that it is a limited resource. So when you're in the coffee shop, you might be very selfish and think, I want my coffee now, but so do the other 100 people around you. So from the coffee shop's perspective, it doesn't just care about you. Sorry, it doesn't. It also cares about all its other customers, all the time. So what could end up happening is it might be in time with the growth, and if the coffee is really good, you might have to wait in line for minutes and minutes and minutes to be able to get your coffee. So that's not cool. What ends up happening actually in MySQL, in AWS Aurora, is that it caps the number of requests at 1,600. So if you're getting even higher than 1,200 requests, you're going to have a really, really bad time, and most likely an outage for half a day. And there's ways to try to optimize that and make your life a little bit better. One of it will be caching. For example, when you've gone to the same place for a while, they already know you, you don't have to go place an order, they just give you the coffee. And the other trick would be connection polling and multiplexing, which means rather than firing 10,000 connections at the same time, you group them. So instead of 10,000, you just fire one, which puts less pressure on the database. And then you leave the backend, and the connection multiplexer. Proxy SQL would be a good example of such software to handle and return the data to the requests that actually need it. So that's pretty cool. Okay, so now we know how we retrieve our ingredients and how we go and place an order. How the hell does coffee happen? Magical liquor. And I've purposely kept the backend out of it, and I've skipped to the actual database because it would be pretty hard. We'd be here for a very long time if we would try to even come up with like a few patterns or details on what a system or a distributed system looks nowadays. The reality is that like the complexity of with all the powerful databases and different languages, our systems are becoming, or the problems that we're trying to solve, the systems that we're building are becoming incrementally more complex. Complexity can be just system complexity at this point. You kind of get what I mean. There's this really good paper about it if you want to know more. But the point here is that it will be very hard for you to always predict how this system will behave at a given time. And when you've deployed the change in production for a while, chances are that at some point you're going to go, what happened? What? I don't even know that was possible. There's always that snowflake logic and that unexpected thing that happens, and then if you're lucky, it doesn't page you at 2 a.m., but sometimes it does, and then it's horrible and you want to cry. And Charity Major said this really, really well. She's the founder of a company called Honeycomb. And she said that in time, as your system grows, as you add more engineers, where you're trying to support more features, the majority of your questions will tend towards the unknown. So are we doomed? Are we just, the system is a black box and you can't do anything about it? Well, not really. What you can do to make your life easier as an engineer is build resilience and error handling into your application, but also making it very safe to fail, making it very safe to deploy and roll back, and use your data to actually be able to observe your system and ask it questions. And this idea of, because it's impossible to know everything about your system, or there's always something that will take you by surprise, got to the term of observability, which you probably heard a lot about it. It comes from control theory, so says Wikipedia and a bunch of other places. But the way I understand it is that you have a bunch of data from your system, and ideally you should be able to craft a story to help you understand how your system behaves when facing unknowns. So you're able to tell a story about your system when it's up, and it's really happy and serving requests, and you're very proud of your latency. And when it's down and making people miserable, and you're getting 10,000 requests from your peers going, what the hell is going on? Your app is down. So when we say data, because again, data is one of those like catch-all buckets as well, what I mean by that is tracing data, logs or events, and metrics. So let's dive into that a little bit more. Tracing is allowing you to answer questions like, where am I spending most time in? This request took 10 milliseconds, if we're lucky. From those 10 milliseconds, how do you break that down? Where have I spent the most time? How fast did my database answered? How fast did this controller returned or like made a call to a worker, for example? So more simply put, it's understanding the control flow within a distributed system. It's also quite good if you have a monolithic app that's been around for years, which is, as startups grow, that's usually the case. It's a very good high level of the structure of the code, so allowing you to actually understand what coding paths are being hit when a certain request comes in. And how many calls to your database are actually occurring from one request. Depending on how you're what you're trying to do with a request, it might be one call to the database, or it might be 20. And obviously, the fewer you have, the less pressure you're going to put on your data storage. So that would be an interesting information to know as you're trying to scale your business. It looks something like this, which is quite cool. So it's literally like a visual representation of all the different hops. And there's a bunch of people that are doing that right now. There's tracing is actually a standard. It's called open tracing, and there's a company that started with the exact same name. The other company that has just started supporting tracing for apps, they're called Honeycomb. Both are really cool. They're doing really cool stuff. So it would be if you want to add that in your app, it would be a good place to look. Logs. Logs are probably from the 3 pillars of observability, which is tracing, logs, and metrics. Logs and metrics are probably the most popular and the most controversial. Just so that we're all on the same page, let's go over what's a log real quick. A log is a record of discrete events that happened over time. Yay. And it's kind of a source that knows everything, what's happened on this service at a given time. Nothing controversial there. Where it starts being a little controversial is that no one really does logging on one way. There's no real standard when it comes to logs. There's a bunch of hopes and dreams. The reality is that most of logs look something like this, a mix of structured and unstructured data. And you have structured data in there if you're lucky. But it's kind of like a blob of a lot of things that are just being dumped in there. This is an example of a request from Rails. So the parameters are JSON, because that's fun. And then the rest are key values, key equals value, and then they're separated by space. As you can imagine, and as I'm sure you know, string processing is not particularly getting any cheaper or any faster. Or easier to do. Most of the vendors will have to run aggregation. They will charge you per that aggregation, and then you're also going to cry if you have terabytes and terabytes of logs, and you're trying to filter through all this unstructured information. So structural logs is the TLDR. It is not 1998 anymore. We're trying to talk about coding to infinity and beyond. Before we go to space, can we have structured logs? This is something that I'm going to leave you with today, if there's one thing that you take from my talk. So once we've kind of picked up on that, I guess a good way to improve logs would be to add some structure. And then you maybe have some tags in there for your log lines. But what this doesn't do, what structure doesn't give you, is still the ability to answer some questions about the environment where this request occurred in. For example, if I want to answer a question like, how many requests per second is this user making to my stack via X? Do you know? I don't know. I have no idea. From just by looking at the log lines, that information isn't anywhere. So that's when a log context is where the context that is missing is what's essentially moving a log from being just a blob of data that is completely useless to actually becoming more an event and actually giving you context and helping you troubleshoot and understand problems a little bit better. And this idea coined something called canonical logging. That is basically a set of fields that describe the environment where that request occurred, like the host, the cluster, the IP, the user, the browser of the user that made that request, the hash of the release, so that when something happens, you can go, oh, see this problem here that generated this trail of 5xx? It was deployed there. So much better. And it's a middle ground between the effectiveness of metrics that would give you an answer very fast. This is a number, boom, we're going to talk about that in a little bit, and the details of log traces. So it's actually not that hard to do. It's literally being deliberate about your fields. A lot of this in the talk is just about being deliberate about what you need. And if you remember the question earlier of how many requests did this admin do to this stack, all you need to add is just the admin ID, cluster, host, release, the remote IP, request ID, service, user agent, timestamp, done. Takes 5 minutes. And then it goes from you being unable to answer a bunch of questions to having a wide range of questions that you can now answer using this log. For example, how many 400 requests did this admin make? Here's a number. So much easier. So the idea of context and structure and thinking of your logs as event records rather than just a blob of information that you can use for auditing purposes is going to allow you to craft a story. It's going to allow you to be more fluid and flexible about the questions that you're going to ask. And it's also going to support high cardinality questions. And more importantly, support high cardinality questions like breaking down by app, by admin, by cluster, et cetera, in a more in a cheaper and faster way, which when you're trying to debug is pretty life-changing. But I know what you're going to think. You're going to say, well, if logs are events and all I need is a bunch of numbers, can I just not use metrics and not do all that work? That seems still quite hard. And the answer is that maybe, but only for certain things. Metrics are built to provide simple answers very fast, but they will only provide answers to a set of predefined questions. For example, how many requests did this API receive over the last hour? Here's a number. What's my average latency on this cluster? What's my average CPU on this cluster? And it's about the known unknowns. So if you know about it, you can obviously monitor for it, or you can obviously have, like, you would know what you would need to record and store. And metrics are really good when you need facts over context. I don't need to know the context in which those 500 requests occurred on the internal API. All I need to know is how many of them were and what was the latency of those requests. Which makes alarms very good for, which makes metrics very good for alarms. If you care about something and you want to be woken up in the middle of the night for it, or your business cares about something, then metrics are a good base for those alarms. Metrics are also historically easier to work with and visualize. So if you want to see trends, for example, how did the traffic increase over time, metrics are a good way to do that. And you can also measure the impact that a certain change had, where, again, if you want to provide a report on the numbers or do some sort of analysis, metrics are a better fit for that. The problem with that, and because they're so easy to use and they feel so cheap to add, what the majority of us do is that they get a little excited. And every time there's a problem, what you end up happening is adding more metrics. And I know what I'll do. I'll add this dashboard so that next time when this problem happens, I'll see it right there. And I've joined an operational team about a year ago in a company called Intercom that I used to work for. And we had, I think, 900 and something dashboards. So what ended up happening is that rather than actually being efficient and I know there's a dashboard and I'm gonna jump right in and find the answer, you'd end up being kind of scared and go, I don't remember where this dashboard was, shit. Rather than focusing on asking questions and solving the problem, you'd freak out that you didn't bookmark a dashboard. And then there's Slack alerts and notifications, which is where alarms and metrics are sent to die because no one really looks at them, and you just keep getting buzzed by Slack, and it's really annoying, and you can't do your job, and you hate everyone. So that's not quite good. And then with the multitude of dashboards, they're not very good at telling you how you're supposed to feel when you look at them. Ideally, there should be some sort of line that would tell you, hey, is the fact that my CPU at 30% a good thing? Maybe it's not. Maybe it was at 10% the other day, and this is actually a problem. Is my job latency, is it okay to be that way? Well, I can see that there's actually like a benchmark that says that I haven't passed it. There's a threshold on the red line that I haven't passed. So yeah, I'm probably good. That's a much more informative dashboard. And numbers are not really chatty, and that's why we should always, if you do have to have a dashboard where you do have to visualize something, you should be very explicit, and it should jump at you the way you should feel about that through thresholds. And ideally, those thresholds should come out of load tests rather than just putting a number there and confusing everyone. Also, you can't really capture everything. Right? You might be very tempted to like, I'll just add another metric, and I'll just add another tag, and I'll just, it's fine, I'll look at it. I'll look at it when something happens. Vendors still charge a lot for metrics. It's still, and then again, it doesn't do anything to prevent the problem that you're actually trying to solve, which is, should I really care for this? So there's a really good talk by Tom Wilkie, which I hope I pronounced his name right, that is basically saying that, hey, for your metrics, try to not overdo it, and simplify it to the request rate, error rate, duration of request, and then you should probably care about the degree in which your app is utilized, the saturation, and the error metrics, and you're done. That's all you need. It's very, very unlikely that you're going to ever run into a situation where you need more than this. Or in simpler terms, am I willing to get out of bed for this? I don't know about you, but I like to sleep, so I don't want to be paged for things that I don't really care about. So this was quite a big talk. We've been through quite a journey. Why should you care about all of this? Well, the idea is to support your system in a real environment and be able to ask questions at the right time and be able to support your learning experience and also your team's learning experience in a sane way and in a productive way. And also because noise is something that, in time, it will absolutely burn you out. And we haven't quite, the tools that we currently have are not necessarily doing us a service at the moment, and it's not, they're not helping us make sense of all the data that we're bombarded with, that we're going to keep being bombarded with as our apps grow. So that's not good. And also because raw data is just noise. You can't really do anything with it, so you tend to stumble, you tend to be slow, and then you tend to doubt yourself, and then it's so much harder, and it's not the humane thing that you should do for yourself or for your team or for other teams as well. And the idea is also the fact that we need to create change. We need better tools. Honeycomb is only around for maybe like a year and a half. Again, we still run Nagios, which please raise your hand if you've had a good experience running an Elk stack or Nagios, and if you haven't like hated yourself when you run any of those things. Yeah, there isn't one. It's kind of horrible. Elk stack is still painful to run. I haven't seen any single talk on logging or Elk that would say this is a breeze. I love doing this. This is awesome. There isn't. And we need to learn together. We need to grow together. And as there's always been this chat of should I be a generalist or should I be a specialist? And I think usually the change, if you look at the tools that are starting to happen, for example, Honeycomb, like ideas come to happen when you learn from people that have a different experience, where you gain insight from people that have a different experience, and then you kind of go, oh, I've never thought about that problem that way. I think I actually know how to fix it. I think I actually know how to help you. So that's kind of cool. So we need to do better about empowering each other and be able to see or look at a problem from a different perspective and be able to support a learning, healthy, happy work environment and sane work environment where we don't get paged in the middle of the night anymore and we don't make people feel like they don't know what they're doing. So before we code to infinity and beyond and go conquer stars, it would be great if we could, I guess, work together to find more creative solutions and identify those pinpoints that are really like dragging us down and making us feel miserable, and ask questions and be a little more fearless. So in this happy note, thank you very much. It was fun to be here.